repeating how to do dimensional analysis. You might also call it factor label method. You might call it unit conversion. They all mean the same thing. They generally have a look of some kind of a fraction with a times, some kind of a fraction and a times. Some people like to do them like this. You could choose whichever way makes you comfortable. The key to doing these kinds of problems is to know where to start. If there's only one number in the problem, that's the number you start with. If there are multiple numbers, you're going to pick the number that only has one unit associated with it, something that's not tied to something else. In this case, we only have one number, so that's where we're starting. So 14 kilometers. And we want to know where we're going. We're going into centimeters. So you might like putting centimeters, question mark, if you'd like to know where you're going. Times. Now, if this is something you are not comfortable with doing, put all the units in first. You always, without even thinking about it, put the first unit you have diagonally down, and you're going to keep doing that the whole time. It all works on diagonals. Then you're going to say, where am I going? Now, if you're especially good at this chart over here, and you know how to get from something with a prefix to something else with a prefix, then you can skip the middle step. But I'm showing all steps here. And I do recommend all steps unless you are very, very familiar with this method. So this is a prefixes chart, and this works for metric units. So metrics, those are all the things like a meter, a second, a liter, a gram, all those things. You can find these charts on the internet. You can find them in your book. They're all over the place. Sometimes the largest is at the top, the largest value, and sometimes they have these listed completely in reverse where the largest can be in the bottom. In this case, we happen to have the smallest at the bottom. It's not the vertical position that matters. It's what we're going across these horizontally. That's what matters. Another little note is that if you know all of your metrics conversions and you can do this without a chart, that's fine too. If you learned all of your conversions in terms of something like there are 100 centimeters in 1 meter, that's fine. If you're just not familiar at all with metrics and are going to be relying on the chart, that's how I'm going to show how to read this chart. There may be some metrics that you're unclear about, so it may be helpful also for you to read this chart. Some people like to put everything as positive exponents, so that's why I'm bringing this up. This chart has all of the 10 to the somethings in one column. When you see that, what that means is that, and sometimes this column's in the middle, sometimes these are reversed on the charts. You can just print off the chart you like. But what that means when there's a 10 to the something and it's all in the same column is that this goes with the base unit. And what we mean by base unit is any of these. So if it's a meter, if it's a liter, if it's a gram, the number with all these tens in it, it goes with the base unit. So this whole time I could be talking about meters. Every time that's the meter. Or let's say, like in some of the other problems, this is a gram. Again, all of these are grams. Seconds, whatever works. We'll do some examples. And then you also always will have this prefix column. Now, very rarely does the prefix column have a 1 in front. I've added those to emphasize the point. Most of the time, it just has a list of prefixes, and they expect you to know that there is a 1 that matches the prefix. So this is how you read these charts. Let's say we're talking about a meter. So I'm going to be talking about a meter, and let's say we're trying to relate a meter to a kilometer. So I need to find the kilometer. So this is kilo, that's kilometer. So here's my kilometer, and I go across. So I'm talking about meters. And what this means is that 1 kilometer is equal to 10 to the third meters. We'll do a different one. Let's say I want to do a microsecond related to a second. Here's micro, and we're going across. So microsecond equals a second, and it works like that. One more. Let's do a gigaliter related to a liter. We would say 1 gigaliter is related 10 to the 9th liters. So do you see how the 10 to the somethings are going with the base units, and the things with prefixes are all getting ones? That's how you read these charts. And every time you get these, you don't start with anything that you get on this chart. This chart is a conversion relationship. It helps you move from one unit to the other. But notice that we are only moving to the base unit. If you have to go from, let's say, a giga right here down to a centimeter. Oops, I went too far. Do you go from a giga to a centimeter? You're staying on this side. You can't relate and say 1 giga is equal to 1 centimeter because they're not related. If you're comfortable and you know how to work this with using these exponents, you can do it that way. But I'm recommending, again, especially if you're uncomfortable with this method, that don't try to go from a prefix unit to a prefix unit. Go instead, and I'm going to do this in red, start at your gigaliters and have the relationship to the liters. And then once you have that relationship to the liters, then go from a liter to a centiliter. So what I'm saying is that you're going to always go to the base unit, move to the base unit. And if you have to go to another prefix, then go to the next prefix unit. So we're going to practice using this chart. So in this case, we're going from a kilometer, and it wants us to move into centimeters. So I've got a prefix and a prefix, so I'm going to go to the base unit, and then I'm going to go to the centimeters. So I'm going to be going to meters, and then I'm going to go from meter to centimeter. So I'm going to look at my chart. I'm going to erase some of this. And the relationships that I need to use are centimeter to kilometer. I'm sorry, a kilometer to a meter. So that'll be here. And a centimeter. So I'm going to put an M here so we don't forget. These are what equal each other. So for the first conversion, I'm going from a kilometer to a meter. So there's 1 kilometer. The prefix always is what gets the 1. And the 10 to the something is what the base unit gets. So 1, that's the prefix, and 10 to the something. And then if we go over here, the prefix gets the 1. And then this is 10 to the something. So 1 centimeter is 10 to the 2 meters. If you like to understand this conceptually, what we're saying is that this meter, everyone probably knows that a meter, it's only like the length from the floor to a doorknob, but a kilometer, that's quite a bit farther. You can run kilometers. And so what we're saying is that it takes 1,000 of something that's really small to make 1 of something really big. It also shows it over here. So we have something really, really small, and we have something big. And what this shows us is that it's going to take 100th, like a very tiny increment of a meter, to equal a centimeter. If you want to put 100 centimeters in 1 meter, you can. Just remember that when you're doing that, you're not using this chart, and it will still work and you'll get the right answer. But if you're solely working off the chart, you're going to be setting it up the way I have this written. And then you're going to put this in your calculator. So I'm going to put a calculator up. We're going to use the E key. Now we're going to use this special key in the calculator so that we can put these in the calculator correctly. And that key requires a number in front. There's going to be plenty of times when you're using the EE or the exponent or the E key. They might be represented like this on the calculator, like this on the calculator, or even just like that on the calculator. Sometimes they're a second function. On this calculator, it's a second function, so I have to push second, and then I have to push that EE. Like for mine, it's above the comma. And it comes out looking like a single E, even though the key itself says EE. 1 times 10 to the. And the reason I've done it this way is that the section that's in red is what's covered by this E key. The times 10 part, that is covered with this key. The advantage of using this key is it lets us get away from having to use a lot of parentheses in our math and keeping up with what the different parentheses are doing it. So I have 14, and I'm going across, and then I'll go along the bottom, times. And then I'm going to use the 1. Notice that's not part of the E key. Now I'm using my EE key, my exponent key. Then I'm going to say 3. That's how I key this number in. It's a 1. It's the EE. And then the 3. I'm not going to have to put in my 1s. I could say times 1 and divided by 1, but you don't have to do any of that. I'm going to put my other number in there. This is how it's going to look putting it in your calculator. For this 2 at the end, the minus, I had to use the little negative with the parentheses around it. You can't use the minus key. It has to be the negative with the parentheses around it. And so I get 1, 4, 0, 0, 0, 0, 0. I need to put this in scientific notation. I want my decimal to end up right here. That's where I want it. 1, 2, 3, 4, 5, 6 places over. So it's 10 to the, and it needs to be a positive 6, not a negative, because this is a big number. So how do we know what unit we're going to use? You'll see how we've matched up the units diagonally. So the top unit of kilometers cancels with the bottom unit of kilometers. The top unit of meters cancels with the bottom unit of meters, and that leaves us with centimeters. If you're wondering about sig figs on this question, well, when you're staying within the metric system, this is considered an exact number, and you can ignore it when you're doing sig figs. Now that's for metrics. So this has 1, 2 sig figs. So that's why our final answer has 1, 2 sig figs.